In the previous class, we discussed about the basic quantities in AC circuits. In continuation with that, we are going to discuss about the sine wave equation. So the sine wave can be represented with an equation. So generally, the sine wave can be represented as Vm sine omega t. Vm sine omega t. So this is nothing but Vm sine omega t. So with respect to the reference, this can be represented as advance. So this can be represented as plus phi. Bm sin omega t plus phi. See here it is delay. So this can be represented as Vm sin of omega t minus phi. So this is the general way we have to represent the sine wave equation. Now we are going to see the various values and various terminologies associated with the sine waveform. First one is nothing but instantaneous value. So it is nothing but the value of the sine waveform at any given instant of time. For example, at the time period of 1 millisecond, the value is nothing but 4.2. At 2.5, the value is nothing but 10. At 5, the value is nothing but 0. So the value of the waveform at any instant of time is called as instantaneous value. Next one, peak value. So the peak value is nothing but the maximum value of the waveform during the positive cycle or otherwise negative cycle. So here the peak value is nothing but 10. So here it is nothing but plus 4 and minus 4. So this is nothing but peak value of waveform. Next one, peak to peak value. It's nothing but it's a summation of positive peak plus negative peak. So for this waveform, the peak to peak value can be represented as 8 volt. So the average value, next one is nothing but average value. So the average value is nothing but the value of a waveform under the particular area. So this position and this position. It is the total area under the half cycle curve by the distance. So the distance here is nothing but t. So the area is nothing but integral of 0 to t v of t into dt. So that is the way you have to find out the area. So the area divided by time, distance of the curve, will give you the average value of waveform. So here we have to find out the average value of a sine waveform. So what is the sine waveform equation? Vp sine omega t. So 0 to pi, half cycle only you have to calculate 0 to pi Vp sine omega t into d omega t. So this is nothing but minus Vp cos omega t from 0 to pi. So now just substitute the value cos omega t. Omega t is nothing but pi. So cos pi value is nothing but minus 1. So minus into minus plus Vp. Next one cos 0 value is nothing but 1. So minus into minus plus. So 1 plus 1 2. So 2 Vp by pi. So the average value of a sine waveform is nothing but 0.637 Vp. Next one, root mean square value. So the root mean square value is nothing but it is a measure of a heating effect of a waveform. So the RMS value is nothing but it is the measure of the heating effect of a waveform. So generally the RMS value can be represented as square root of 1 by t integral 0 to t v of t the whole square into dt. Now the v of t value we know. What's the value now? Vp sine omega t. Just substitute it here. So this will become Vp square sine square omega t. You cannot sine omega t square. We cannot able to integrate it. So instead of that, we are converting it into cos terms. So sine theta can be represented as sine theta square can be represented as 1 minus cos 2 theta by 2. So based on that, we have done this equation. So this is nothing but 1 by t. Now again, you just take the integration. So you will get the value as 0.707 into Vp. 0.707 into Vp. So the RMS value, generally the RMS value, Vrms is nothing but Vm divided by root 2. Vm divided by root 2. So next one, peak factor and form factor. Peak factor is nothing but it is the ratio of peak value to the RMS value. It is represented as Vm divided by Vrms. So Vm value we know Vm divided by Vrms. Vrms we know it as Vp divided by root 2. So based on that, the peak factor value is nothing but 1.414. Form factor. The form factor is nothing but it is defined as the ratio between RMS value to the average value. So it is represented as Vrms divided by V average. So based on this Vrms value we know Vp divided by root 2. V average value, what's the value? 0.637 into Vp. Just substitute it, Vp and Vp will get cancelled. So you will get the value of form factor as 1.11. 1.11. Okay. So this is the way we have to find out the peak factor and form factor. So peak factor, the formula is nothing but ratio between peak value to the RMS value. And the form factor is nothing but ratio between RMS value to the average value. So now next one we are going to see the phase relation in a pure resistor. When you're applying a sine voltage across a pure resistor, what is the relationship between voltage and current in a circuit that we are going to discuss? Just consider the sine circuit. It is nothing but resistive circuit. That means you're applying a sine voltage across a resistor. So now here it is a voltage. It is an AC voltage. So now in an AC voltage, this is nothing but resistance R. We are applying a voltage of V. So V is nothing but Vm sin omega t. Now the function can be represented as I is represented as Im into sin omega t. So now according to the equation, V of t, instantaneous value can be represented as R into I of t. So I of t is nothing but Im into sin omega t. So this can be represented as Vm sin omega t. So Vm here is nothing but Im into R. Now Z can be represented as Vm divided by Im. There is nothing but R. That is, when you are applying a AC voltage across a pure resistor, the voltage and the current will be in phase with each other. See here, the voltage and current will be in phase with each other. That is, the power factor of a resistive circuit is unity. The voltage and current will be in phase with each other. Only there will be change in the value of amplitude. Why? Because Im is nothing but Vm by R. So depending upon the value of R, the value amplitude of Im will get changed. But the phase value will be same for both the cases. So this is the relationship between voltage and current in a pure resistive circuit. Next one, phase relation in a pure inductor. So in the case of inductor, instead of resistance, you are connecting an inductor. We know the value of voltage across inductor. It is nothing but L into di by dt. Now the I of t is nothing but Im sin omega t. You just substitute it here. So this is nothing but Im sin omega t. So when you are taking the differentiation, this will become L omega Im cos omega t. So now the cos omega t can be represented as sine of omega t plus 90 degree. Sine of omega t plus 90 degree. That is, I of t will be like this. But V of t is nothing but Vm sine omega t plus 90 degree. That means it is advanced. Or otherwise, the current lags the voltage by 90 degree. The current lags the voltage by 90 degree. That's why we are having a lagging power factor in the case of pure inductor. So now this can be, omega L can be represented as XL. So that is nothing but XL. So this omega L is called as inductive reactance. So the pure inductor will have a impedance value that is equal to omega into L, where omega is again represented as 2 pi s. Omega is again represented as 2 pi s. Okay. So this is the phase relationship in a pure inductor. So when you are applying a voltage across a pure inductor, so now the current lags the voltage by 90 degree. Next one, phase relationship in a pure capacitor. So in a pure capacitor, the voltage can be represented as 1 by C integral of I of t dt. So I of t is nothing but Im sin omega t. Now based on this, you will get the value as minus cos omega t. Minus cos omega t can be represented as sine of omega t minus 90 degree. So you are having a I of t value. The voltage lags minus, so it is lagging by an angle of 90 degree, or otherwise the current leads the voltage by 90 degree. That's why the capacitance, whenever you are having a capacitance in the circuit, you will have a leading power factor. So here also the Xc is nothing but capacitive reactance. It is represented as 1 by omega C. So when you are having a pure capacitor, the impedance value is nothing but capacitive reactance, that is equal to 1 by omega C. It's nothing but capacitive reactance. So when you are having an inductor, you will have an inductive reactance, that is nothing but XL is nothing but omega L. Same way Xc here is nothing but 1 by omega C. 1 by omega C. So now we come to a conclusion that in the case of pure resistor, the voltage and current will be in phase with each other, and in the case of inductor, the voltage and the current lags the voltage by 90 degree. There you will have an inductive reactance of XL. In the case of pure capacitive circuit, the current leads the voltage by 90 degrees, so you will have a leading power factor. So in the case of capacitive circuit, you will have capacitive reactance, that its value is nothing but 1 by omega C. And also we have seen the various basic parameters: instantaneous value, peak value, average value, and also we have discussed about RMS value. Thank you.